Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 3C and Mathematics 4, Swedish education system. The definition of the derivative. Hi, this is Babak. In this video, I'm going to solve the following problem for you. Use the definition of the derivative to determine the derivative of the following function. F of x equals to 2x minus 1 over x. I recommend you to pause the video at this point and try to give it a try yourself. If you can solve the problem correctly, the final answer that you will get is f prime of x equals to 1 over x squared. Okay, now let us start solving the problem together. I want to use the definition of the derivative to find the derivative of this function. So the first thing that I need to know is the definition of the derivative of the function f. And you know that this definition is a limit of f of x plus h minus f of x divided by h when h goes to 0. Okay? Of course, I can start immediately calculating this limit, but here I immediately realize that this function can be viewed a little bit simpler. I can simplify the function a little bit first, so I would prefer to do it whenever it is possible. So I would write f of x is equal to, I take this one and then divide it by x minus this one divided by x. So this becomes 2x divided by x minus 1 over x. But then this x and that x are cancelled, so what I get is 2 minus 1 over x. So I would prefer to work with this form of my function, which is 2 minus 1 over x. The calculation becomes slightly simpler if I do this simplification first. Okay, now let us go back to the definition of this and then try to calculate this limit for this particular function. So I have the limit, fraction line here, bottom line is actually h goes to 0. Then you see that I have a minus sign here. On the right side of this minus sign I have my f of x, so I replace this one here, but because my f of x has more than one term, so it is crucial to remember to put a pair of brackets around that and write simply 2 minus 1 over x. But for this part, what I need to do, I need to go to my function f, replace every x in the function with x plus h. So when I go to my function, there is only one place that I see x. I take it away and replace x with x plus h. So it becomes 2 minus 1 over x plus h. And then I have to calculate this limit. So how should I calculate this? The first step is to simplify this algebraically. So I would write 2 minus 1 over x plus h, open the brackets, minus sign goes for the first term, it becomes minus 2, and for the second term, so it becomes positive 1 over x, and the denominator is still the same h goes to 0. Then you immediately realize that this negative 2 and this positive 2 are cancelled, and then what is left for me is the limit. I myself prefer always to write the positive one first, it doesn't matter, but I am used to this, so let me just follow my own way. So this becomes this, and then I have h, in the denominator h goes to 0. So the first thing that I do here, I first of all get rid of all fractions possible. To do that, I need to find the LCM, the least common multiple of all the denominators. So there are two denominators involved in this problem in the numerator. This is this one and this is this one. So I will have x and x plus h. Because x and x plus h doesn't have any factor in common, so the LCM is simply just the product of these two, which becomes x times x plus h. So then it means that I take the numerator and multiply it by x times x plus h, but because I'm not allowed just to change the problem. For not changing the problem, I also have to multiply the denominator. So I multiply the numerator by this, and I multiply the denominator by this. Multiplying the denominator is very simple, so what I need to do is just to write x times x plus h here, but this one should be multiplied here and here. Yes, if I multiply 1 over x by x times x plus h, x and x are cancelled, I get x plus h, and then when I multiply this by this term, it becomes 1 over x plus h times x plus h. This time x plus h and x plus h are gone, so what is left for me is x. So the first term turns into x plus h, the second term turns into x, and there is a negative sign in between here. Yes? So this becomes simply the limit. Let me change my color. This becomes the limit x plus h minus x, but in the denominator, as I explained again, I have h, then I have x times x plus h. So this way is always simpler, it is faster. So I found the LCM, I multiplied the numerator and the denominator by the LCM, and then I simplified that. So you see that I have just one single fraction now. Here I had one fraction, but in the numerator I had two more fractions. But here now I have only one fraction involved, and as usual here h goes to 0. But then it is easy to see that this negative x and that positive x are cancelled, and what is left for me in the numerator is just 1h, and the denominator I have three factors. One of them is h, the other one is x, and the final one is x plus h as a whole. H goes to 0. But then this factor of h can be simplified by h, which becomes 1. This also simplified by h. So I am dividing the numerator and denominator by h, so I will get this expression. And then if I continue, so the numerator is just simply 1. The denominator is x times x plus h. H goes to 0. Okay, so here in the beginning I had some problems if I want to replace h with 0, but now because this h is from the numerator and the denominator is gone, I don't have any problem left, because if I put h equal to 0, this becomes 0 plus x, which is no longer 0, so I can just put it here, so this becomes 1 over x times x plus 0. But x plus 0 is just x, and x multiplied by x is x squared, so I have 1 in the numerator and x squared in the x squared in the denominator. So this means that what I get is f prime of x is equal to 1 over x squared, and that is the answer to this problem. Okay, so I hope that this video was somehow useful for you. Thank you for watching. Be safe until the next video.